Welcome everyone to the June meeting of Geology Club. On behalf of your leaders, Tina Kruger, Joe McNamara, and myself, and as well as Sylvia Eppig, Vanessa Burnett, Joanna Colvin Gamble, Mike Fowler, and introducing the newest Geology Club team member, taking care of promotions. See this nice shirt that I've got on? These shirts that have now gone out, we have 10 shirts out in the wild to members. Basically, these are all coming from her. The pens, the cups, the stuff that's coming our way, that's all going to be coming from her. So we've added her to the team. We welcome her and thank her. Thank you, Samantha, and welcome. So I just wanted to go through real quick. I'm trying to move this window out of my way. Here we go. All right, thank you. All right, so Geology Club is a 501c3 nonprofit unincorporated membership association here in Pennsylvania and across, that's national 501c3 and the unincorporated membership thing in Pennsylvania. We're registered in both. And it's designed to be an updated, future-focused version of the standard Mineral Club model. Built to engage new audiences, Geology Club aims to rejuvenate, revitalize, and revigorate how the rockhound experiences, interacts, learns, and grows with others through an innovative and accessible educational geological community. That's all to say one big thing. We are dedicated to support, help, promote, and work with other clubs to grow the community as a whole, to provide support for those seeking geological knowledge. We are dedicated to this. We are not against any other club out there. We want to work with all of them. And tonight we are going to talk about a trip. Professor Steve Lindbergh is here that, we will be trying to invite, if with his permission, more than just Central PA and us. We've always shared trips with Central PA. We'd like to go farther. We'd like to do some events and spread throughout the community good love and goodwill towards all rockhounds. And that's what we're dedicated to. So I just wanted to make sure everyone knew that, start off right off the bat just by making sure everyone knew that. All right, so real quick, Bedrock Bulletin. Hope you liked the last one that we just sent out about last week. I think we sent that out. Just a reminder, we want your contributions. Rockhound of the Month submissions. You'll have a new Rockhound of the Month tonight that we're going to award. We've got a great trip recap video, but we always want your pictures. We all know that you're taking pictures of your specimens and stuff. Send them our way. We want to see them. All right. We also need some more beta testers. So we are close to releasing a brand new app. Several of our testers have already given us some great feedback about it. So Mike will be talking more about this soon because I would like him to, share with everyone because he's really been the brains. He's a genius and he's been the one behind this whole thing. So soon, hopefully by July, we'll see. But we have a rock identification app that is based on the Northeast rocks. It seems to be going well through beta testing. Some, really, it's based on the Northeast minerals. So if you try to get something from California, it may not work for you. But for where we are, where all of us pretty much are located, this will really help you walk through the real geological tests, not using pictures, not all that. You're actually going to scratch it. You're going to do all the different things that a normal geologist would. And this just helps you do that. So that's coming your way very soon. And then we have a couple more things that are really cool. So if you want to get on behind the scenes, send us an email. Michelle Bodery, I did just get your email. I sent you a reply right before this meeting. Let's talk. I know you want to get involved. All right, Geology Club Youth Director. I want to do so much more than we have already done for our youth. We have close to 100 youth already, if not already. We need to do more. We have a lot of awesome things that we could be doing. I just don't personally. I'm the one taking care of doing the youth program right now. It's just my throughput is maxed. So we'd love to have more help in that respect. So please, if you would love to pitch in. If you'd love to be our youth director, we would love to talk with you and see what you can bring us. We could use the help. Okay, getting on to the exciting things. We have more on the way. Vanessa, do you want to take this over and talk a little bit about these trips? And then when you get to New Paris, we can, well, New Paris is at the top of the list. Let's just start off right off the bat with Professor Steve Lindbergh. If you could unmute 7/11, July 11th. We are going to all go out to New Paris. This is the trip I would like to share, not only with Central PA, but maybe DMS and FMPA. Let's get a group going, if that's all right with Steve Lindbergh. But Steve, if you could tell members about New Paris and why they should drive out to Bedford County and go see the tunnel fire, at least the remnants of it. And,
Okay, so July 11th, you are welcome to come to the New Paris Limestone Quarry in Bedford County. It's about 20 minutes off the Bedford exit on the turnpike. Yes, youth are allowed, but I would prefer if they are at least junior high school level. The quarry is this is a quarry that was actively mined by New Enterprise Stone and Lime, and then it went inactive and it was sold to the private landowner that owns all the surrounding property, and we have turned it into a geoeducational field site. So there's no charge. It's free. You can collect as much as you want. If you want to take 5 tons of material out of the quarry, you're welcome to take out 5 tons. When the quarry was being actively mined, it was famous for the purple fluorite that occurs in several large veins along with white calcite. Since it's no longer actively being mined and blasted, there's still lots of purple fluorite there, but it's becoming a little bit harder to find because we've had quite a few groups there, including Geology Club a few years ago when we gave Andrew his award. Franklin County's been there several times. Other Jerry Jones group has been there. So as I said, it's free. You're going to need, it's really, there's no restroom facilities there, but there is a nearby gas station about 2 or 3 miles away. I suggest you bring lots of water, food. There's places to park right above the quarry. What else should I mention? The quarry is unique because it has been highly studied. We have quite Pitt Johnstown Geology Department. We published a pretty extensive field guide to the geology of the quarry. We've had a lot of students doing work there. We currently have a student doing geochemistry analysis of the fluorite. We have dated there's volcanic ash layer beds there, bentonite beds. That contain zircon crystals, and we have collected those zircons out of the ash and sent them out for radiometric dating, and we're getting dates back of about 415.7 million years, which places it in the lower Devonian, upper Silurian, and that's another unique thing about the quarry. There are very few places where you can actually stand and place your hand on the boundary between 2 geologic periods, and this quarry marks the boundary between the upper Silurian and the lower Devonian, and there's a transition zone in there. Dean Rucco, who a lot of you might be familiar with, several years ago made the discovery there of eurypterids. So we now have confirmed eurypterids in the New Paris quarry, and he's written a short paper on that that's actually appeared in our NAGT newsletter, and it's in our geological guide. So what else should I mention, Andrew?
Nope, that's good because you do a whole great presentation when we get there on the most of the history of it. So thank you, sir, and we are very excited to get out there. I always love getting out to that quarry. There's a couple Dirtman reports if you want to check it out in video form on YouTube. Just look up New Paris. I think that was the title of most of them. So yeah, Vanessa, take it away.
We have a couple great trips coming up. We did our first trip to the gun club this past weekend. I think it was a great success. Everybody had a lot of fun. We found a lot of interesting specimens along with some turtles. And then we have Texas Quarry coming up. In July, we also have Mohawk Mountain. We're going to do Diamond Mountain that same weekend. We have 20 free passes for Diamond Mountain. So we'll do it like we did last year. We'll have everybody sign up. And then if we have more than 20, we'll do like a lottery to see who gets the free passes. You can camp out if you want to at Mohawk Mountain. He doesn't charge to camp. I don't have the prices yet for Mohawk.
I do. Let me jump in real quick.
Yep.
I just talked to Scott, the owner.
Okay.
We have a special code if you sign up online to be there either 18th and 19th, both days, if you don't get in on the Diamond Mountain trip, or if you just do one day. There's a special code AR50. If you put that in checkout on the Mohawk site for either the 18th or 19th, if you do both days, you get both days for $80. If you do one day, it's one day for $50. So a bit cheaper than the normal price.
Okay, perfect. So that's Mohawk, and then camping's free. And then we do have 3 more trips to the gun club coming up. And then we have the Area 52 again. We had a great time up there, even though it poured. We found some really amazing pieces up there. Shane is fantastic, absolutely great guy. He was very helpful to everybody. And then we also have High Street coming up at the end of September. We might put some more in here and there, some smaller trips, in August, but we'll have to see time-wise. But we have a lot of exciting things coming up.
Samantha, really quick, can you give us a rundown? Because July 18th, 19th is a triple header, really. We have 2 trips in New York and then a trip in Ohio at the same time. So, Samantha, can you just give us a little rundown on the Orton Geological Museum and Caesar Creek State Park?
There we go. All right. So on 10 a.m. on the 18th, we have a private tour of the Orton Geological Museum set up. And then it's about a 45-minute presentation he gives. And then after that, we're going, lunch. Everybody can be off for lunch, and then we'll come back to Caesar Creek State Park, and we'll do some fossil hunting at their spillway. And that goes until whenever, because, I think it's only open until like when dusks. But even at that, people can camp out there if they want to. You just have to stay for 2 nights since it's on a weekend. If not, then that's all right as well.
Cool. Thank you. That should be an awesome trip.
I have one more, Andrew. I forgot to mention on September 13th, we have the Hewitt Gem Mine in Connecticut. We also have that scheduled.
All right. So we have a huge slate coming up. We're also going to do new Ringgold. We'll do a luncheon kind of thing out there, or hot dogs or hot chocolate or something. And then we also would love to we're looking at the middle of August for a kind of a picnic kind of thing that we're going to do in Dillsburg, PA, and we're going to do it based on dinosaurs and gold panning and stuff like that. So we have a great site. It's in the shade. It'll be a great time for a great picnic. I still haven't talked to everyone planning this whole thing yet, but there are a lot of things that have already been in the works that we just have to get together. So a lot of things happening. Stay tuned, everybody. So let's see some recaps of some of these trips, because we had a back-to-back weekend of amazing trips. So really quick, we want to show you a pretty cool video. And I want to apologize right off the bat. Depending on your device, the music may get butchered. So Kim, just go to geologyclub.org and sign up as a member, and you'll get trip emails. Non-members do not get trip emails. So if you're new, you will start getting them now. All right, so here we go. This is a great recap of both Area 52 and Lehigh Anthracite. Enjoy. Durman here, Area 52 in New York. It's cold, it's raining, so I'm going to show you a few highlights of some pockets that were pulled out during this weekend before the rain set in. It's going to be awesome.
Geology Club rocks!
Wow. Palmer, whatever you want to call that, that is beautiful.
Field trip, steel toe chain, rain on a yellow school bus
Hell yeah.
lane. Outcrop flies like
so
sleeping
cool.
beast. We trace
Little
their
rider there.
backs, we name their grief.
Just spectacular. Yeah, let's see what's going on over here.
Cinnamon of teenage schemes. Every fossil, every seam spills our name in buried screen. Counted in one spark, flash of light inside the dark. Every fracture, every mark is a wave across the arc. Geology club rocks. We break the ground, we crack the locks. From basement dust to mountain tops. Geology club rocks. Geology club rocks. We shake the floor, we rattle clocks.
That is a nice one, dude.
Geology club rocks.
Wow. Amazing skeletal found by Corey. Oh yeah. To prove how muddy and dirty and rainy this is, look at Katie. She is covered, but she's pulled out some amazing crystals. Look at that. Wow.
All diamonds begin when the ground gives way and the quiet shatters. We scream our name like a fault line fracture. Geology club rocks. We break the ground, we crack the locks. From basement dust to mountain tops. Geology club rocks. Geology club rocks. We shake the floor, we rattle clocks. If the world erupts, we never stop. Geology club rocks.
All right, everybody. Hope you enjoyed that. That was the Geology Clubbers. Harder than granite. Sorry, that was AI. That was 100. That music was 100% AI. But that's kind of been our theme song lately. That I generated that a while back, just for literally a couple seconds of music, and that's what we got. So proud to bring that to you. Here's the whole band. At least they got my mohawk right. All right. So, yeah, we had a trip to Lower Providence Rod and Gun Club on Sunday. Great trip. Lots of great malachite and all kinds of really pretty, almost like azurite, like blues, greens, all kinds of stuff. Wonderful trip. A lot of great people. Look at Jerry Garvik sitting there. He had a great time. All right, and so Vincent Monteleone, he posted some pictures to Facebook. I just wanted to highlight them. The little green jelly ball looking thing in the center, that is just amazing. I believe the lower picture is a blow up of that. I don't know if he's on tonight to talk about these pictures. I don't even know what any of these are, but they're microscopic pictures, images of ones that he had collected himself. Vincent, are you on tonight? Vinny, are you on? Can you tell us a little bit about these? If not,
I don't think he's on tonight.
Okay, cool. No worries. Either way, I just wanted to highlight these because I don't know.
Music right here.
Oh, sweet. Tell us a little bit about these. Thank you, sir.
What do you want to know?
What'd you do? Did you figure out what these minerals are? How'd you take these pictures? Give us a little background.
So the green ball on the top right, or the top left, my fault, is pyromorphite. I guess it's like a bitrudal pyromorphite. And then I believe on the quartz crystals on the bottom left are chrysocolla coated, and I'm not sure what's on the right hand side.
Okay. Yeah, it's like a feathery coating or something. Very cool. So I just wanted to highlight these. These are ones that caught my eye as going through the pictures from Sunday. So I just wanted to highlight those. Great job, Vincent.
Thank you.
Very, very cool. All right. So moving right along. Rock Hound of the Month. All right. Well, basically, we've had an issue where members keep on nominating multiple people. All right. So I was quite excited to see the first name of this, well, both names, but I was instantly floored, and I was like, all right, this man deserves it. So does she. But you know what? I know this man would love to see his daughter win Rock Hound of the Month because it can only be one. So congratulations, Chelsea Lapp. Mike Gretsch, I would love to hand you a t-shirt too, but it can only be one per month. So Chelsea, congratulations.
Hi, guys. Thank you so much. My dad is actually on right now, so he can hear you. He's having a little bit of technical difficulties, so he can hear. So thank you. I am super excited, and I know he is definitely Rock Hound of the Month in his heart for sure. He's the ground score king, so he lives up to the name, and he just loves this club. I think he has more fun finding things and then giving it to everyone. So thank you, and I will share this victory with him as well.
Awesome. Yeah, no, Chelsea, congratulations. I kind of butchered that intro, but it was only to say that I love your dad. Mike, you really do rock, and just the whole ground score king thing that following after, like, just followed around with me. Like, I love it. Mike, you rock. We'll try to get you someone to resubmit you in the future. Hopefully my little speech here will help, someone vote for you.
He'll be excited, and he lives by that name at home. He always says, Andrew says I'm the ground score king. So he's very excited. I can assure you. Oh, he texted me right now. He said that you're his mentor. So thank you guys so much.
Trust me, it's mutual. Mike's awesome. He really does find some amazing stuff.
He gets lucky, that's for sure.
Oh yeah.
Well, thank you guys.
All right, so you will have a shirt coming your way. If you want to let Tina know your shirt size, that way you don't have to tell everyone. We'll get you.
Thank you guys. I'm excited. I'll rep it next time.
Cool. And speaking of which, everyone, so orange shirts are going to stay with the leadership team. That way, when we're on trips, you know who to come to if there's any emergencies. Gray shirts, these Rock Hounds of the Month is a special design for the Rock Hounds of the Month. So they only go to the winners. We also, for members now, we have green shirts, we have pink shirts, and we're going to be making purple shirts as well. Purple has been requested by everyone, so we're going to do that. We don't have them printed currently. We are in the middle of a batch right now. We just had the first 10 that we had printed up are now out with members. We'll be getting more shortly. But we do have stickers and can koozies and pens and stuff like that. So next time you're on a trip, just see if one of us has them. And this is to raise money for the club, fundraising for the club. We have the lowest fees to join out there. So this is just to be able to do things for the members when we raise this money. So thank you everyone. And next most exciting thing of the night. All right, giveaway. So this picture right here was last month's giveaway, actually. I didn't have time to take pictures of all of the crystals, fluorite, fluorescent, flint, pyrite, and malachite, all of which I'm going to give away tonight. So it's not going to show up too well, but this is a very large Area 52 faceted I can never get the facets to really shine, but those are faceted sides right there. So that's a Palmer. I mean, that is a Palmer. So fits in the palm of your hand. So Area 52, you're also going to get malachite from the trip that we just had. Oh my goodness, I put Avondale on there. See that? It's Audubon. I even wrote it wrong. It's just a mental defect. I don't know. So some fluorescent stone from Lake Erie, Ohio, from that fluorescent trip that we had. This is amethyst. This was a piece that I bought from the youth cart. So this was the kids that collected this, and I bought some off of them. So this is going in the thing tonight. Devonian era brachiopods from the Skook. Ohio flint. Pyrite from Lehigh anthracite. Nice pyrite bunch right there. Mohawk Valley, PA quartz, and fluorite from National Limestone. So all of that. Now, everyone, you started putting your number in. There was one more requirement for putting your number into the chat, and everyone's just going ahead and doing it. We were hoping to get a location from most everyone with your chat. With your number tonight, we'd like to know where you're from. State is fine. If you want to put your county and state, that would be great. It'll help our presenter tonight, just with what he's going to be presenting.
Do it if you want to. Do it if you want to, Andrew. Doesn't matter. Keep going with your good giveaway.
No, we're still. So we give we give it away after the presentation. So everyone, go ahead. Start putting that in there. Looks like we are all so far PA, Maryland, PA, New York, Queens, New York, Howard County, Maryland, Berks, PA, Fauquier County, Virginia. I'm not sure what that one is. Nottingham, Maryland, Northeast Ohio. So yeah, we're pretty much around, the Mid-Atlantic. So, all right, I'll keep my eye on that in case we have any crazy ones pop up from like Hawaii or something. But I would like to introduce tonight our feature presentation. Our presenter tonight is Martin Schmidt. I hope I said that right. We have been working with the Maryland Natural History Society. We have a couple members from there, and we've just been talking back and forth. I'm going to help lead, actually Joe McNamara and I are going to help lead a trip for them in Maryland later in the fall. So, this is one of the clubs we've already been working with actively. So Martin has come to us from them. And if you want to give us a little thing about the Maryland Natural History Museum and all that as well, if it's up to you. But yeah, without further ado, welcome, Martin.
Okay, thank you. I'll let you all know. I'm not going to tell you where to go and get lots of crystals, but I'm going to give you the bigger picture of what's out there, and I hope you'll find it interesting. All different stuff going on. The Natural History Society of Maryland formed early in the 1900s, kind of has its ups and downs, but right now we are just recently been designated the Natural Science Museum of Maryland, and we have a new, a lot of stuff that's been changed in the building, improved on the outside. Now we're working on a exhibit on the geologic history of Maryland within the building. And it's in kind of northeast Baltimore if you ever go down that direction. But let me, what I'll do is share my screen and we can get going here. Yeah. Here. Okay. So you should be seeing a good old saddling hill with a long title. Can you all give me some thumbs up if that's what you're seeing? Looks good. Okay. So you'll have to pardon the long title. What we have here's the truth of the matter is that I'm the author of this book called Maryland's Geology. It is kind of just like a Geology 101 course that then applies it to the state. And it's a if you're in Maryland, it's helpful. Even if you're not, what I want to do is kind of show you. Well, it turns out that much of the geology is similar as we move into Pennsylvania and other places. So you can get this book if you want to read the geology part and then apply it to your area. But that's what you can do. It turns out that let me go here. Yeah, sorry. Maryland has what are called has 5 physiographic provinces. The provinces are places that have similar landforms and geology, and you may have heard about these in your travels. The coastal plain is the lowest part. The Piedmont gets into these yellow colors, so it's a little higher. The Blue Ridge is even higher. The Valley and Ridge goes up and down, also called the Ridge and Valley. And the plateau out here gets high and stays high. If you ever drive from Cumberland up to Frostburg, it's several miles uphill to get there. So you get up onto the plateau. It's white in this, not because it's all snow, but because that's the color for the highest area. Well, so we have these provinces, and this is what I've been talking about, and what's their geology. But it also turns out those 5 provinces really extend all the way up into Pennsylvania and all the way down to Alabama. And so Maryland is just sort of a cross section of those and hits all 5. Most of the other states don't quite hit all 5. So it makes it a great place to kind of study the general geology of the whole eastern United States, especially the mid-Atlantic. So that's what I want to kind of explain today. And what this will hopefully do is once you kind of see where you are and where the places you collect are, it gives you some other ideas of other places to go and check out. So, okay. So here we go. Here's Geology Club's motto, watch for rock. You don't have to wait for it to fall on the road. Just go look for it anywhere. This is a real sign in Idaho. How to save money on signs. Make one sign go for the next 60 miles. Oh, but we can bait that. We should always watch for rock, okay? Don't just wait for the 60 miles. So get out there and look, okay? When we look at why would we study geology and what can we get, if a geologist especially goes out, they need to study the land first, discover what's there for the underlying rocks, figure out, look at the rocks and interpret how they formed, and from that they can hopefully put together the geologic history. And so this pyramid here is kind of the way things go for science. Start at the top and work your way down. However, I have found that when we don't have too long to talk about this, it can help to actually go the opposite direction, where we tell what is the geologic history, and then we can figure out, okay, what we find left of that history, and and what do we see? Okay, so that's what I'm going to do tonight, is go in this order. It's nice that the geologic history will apply to everywhere, kind of in this whole area for everybody who's on the call. You all, I'm sure, have heard about plate tectonics. You know, the outside of the earth is actually pieces that are moving around in different ways. And you can see on this map how fast they're moving and what directions at the moment. Well, so the question becomes, how have the plates moved to create Maryland and the eastern United States geologic story? That's what I want to do. So hang on, let me do this. And we're going to switch to a different set. Okay. So here are a bunch of slides that are about what has happened with plate tectonics for Maryland, and it's actually rather similar for other places in the mid-Atlantic. So the whole purpose. This story has to start 1 billion years ago, because the oldest rocks in Maryland are 1 billion years old. This is land that will become part of North America, has run into land that will be part of South America. When they did that, they made a supercontinent called Rodinia. Most of you all have probably heard of Pangaea. But that comes later, and we'll talk about that. But this is the one before Pangaea. Okay? And whenever they collide like that, they make mountains where they collide, kind of like 2 cars running into each other. So the brown on this map shows where the mountains formed in this collision. And in those mountains is where the oldest rocks in Maryland formed, the Baltimore gneiss and some gneiss in the Blue Ridge. We call these the Grenville Mountains. And in different parts of these different states, you all will have some Grenville age rocks in the mid-Atlantic, but they're kind of scattered around. By the way, this picture is from Earth Viewer. What I'm going to do at the end of this is I'm going to put in the chat a whole bunch of links for where to go look at these maps and URLs that I'm using. It's actually a good thing if you don't mess with them right now. Don't try to look for them because that way it won't slow anything down. But I'll give you a whole bunch of links in the chat at the end. And so we'll get to that. This is where we were at 1 billion years ago. We're going to switch to a different kind of picture from now on because it depends on what's available. But this is now 350 million years later. That's enough time for those mountains to have worn down completely. And what's beginning to happen is the supercontinent Rodinia is beginning to rift apart. In the rest of these slides, you'll see a little red dot. Okay, I hope you can see my cursor down here at the lower part. The little red dot there is where Maryland's going to be. Okay, and you can figure Pennsylvania is going to be actually, in this case, a little bit to the right of that, and Virginia to the left, because we're going to actually turn the continents around some. But that's okay. It's in this area is the main point for everybody to know. When this was rifting, as usual with continents, it puts up lava. So here was a spot time when there were volcanic rocks in Maryland and also in other states nearby. So that's kind of different. We don't think of volcanoes as being with us these days. So those continents are rifted apart. Okay, and the part that will become North America is called Laurentia in this map. And the little red dot is here. Notice it is a little red dot, but after all, Maryland's not very big when you put it on a whole globe. So you can figure we're in that general vicinity. Continents tend to subside on the edges when they tear apart. So we got a lot of water over the whole mid-Atlantic states, and the material washing off of the mountains up in here and the land gets deposited in here. As information says, we got sand and limestone and muds deposited. Later on, they're going to turn into the schists and the quartzites and the marbles that we find in the Piedmont, and some limestones out in the Frederick and Hagerstown Valley. And all of these, many of these rocks extend into Pennsylvania and Virginia. So here's when they formed. Move on to the Middle Ordovician, and you all may be pretty well aware of the names for these. We're mostly going to talk about that time, but kind of keep track of where we are. Here we are 458 million years ago. What's going on now is the plates are beginning to shift in different ways, and they're actually beginning to come together. And so you get this symbol, this little pink symbol down here, which is a thrust fault, and it's showing one plate going underneath another one. That generates volcanoes, and due to partial melting, same process that makes the Aleutians today. And so it made a group of offshore islands off here in what we now call the Iapetus Ocean. Can't really see them very well, but the islands are there, because in the next part, what's going to happen is those islands got pushed onto North America because the plates were coming together. This made the second set of mountains here after the Grenville. Now we're talking about the Taconic Mountains. And now you can see Maryland has some land around it. Those are the Taconic Mountains. Interestingly, now we kind of have the reverse of what we normally think of for Maryland and Pennsylvania. And those places, the mountains are in the east, and there's actually shallow water in the west. Whereas now we think of, oh, it's the other way. The water's in the east, the mountains are in the west. But here's what was going on. And from this spot, these mountains eroded out into the shallow sea to the west. And that's a fair number, beginning to make the stack of rocks we find in western Maryland, and a lot of the sedimentary rocks in Pennsylvania and West Virginia as well. So that's when this was going along. There is some other pieces that are still moving toward North America. You see one labeled here, well, it's called Avalonia. Okay, it's going to move toward North America, so that in our next one, Avalonia has pushed onto Laurentia, now labeled Euramerica, and made our third set of mountains, the Acadian Mountains. These were, many of y'all may have been to Acadia National Park. It's kind of where this name came from. And this mountain building event mainly affected New England, but it also came down to Pennsylvania, Maryland, Virginia as well. This is labeled the Northern Appalachians for that, but there's our Acadian ones. Okay. So that's our third mountain range. Things are still closing here because what's going on here at 356 million years ago, Euro-America here and Africa, along with everything else that's attached to Gondwana, is all moving toward each other and coming together at this point. So by 306 million years ago, they've collided to make the supercontinent Pangaea. And so now you can see here's where Maryland is, but it's kind of land all around because Africa has run into it. And we have a big batch of mountains. This is the Appalachians. Geologists also call them the Alleghanian Mountains. Okay. You also notice that it's not very far from the equator. We started at a good 50, 60 degrees south, but we've now made it up to the equator. When you all go to some of the beds that have coal in them, then you're going to see that this is when some of that stuff was deposited because that's usually forms in tropical swamps. So we were in a tropical place and the rocks that we have show that we were. Okay, keep on going into the Permian. The forces that pushed Pangaea together kept on continuing, and they pushed and pushed and made mountains that were higher and higher. This really is the same process that makes the Himalayas today, continents colliding. So we figure these mountains got to be at least the height of the Rockies. Maybe they were higher. So this pushed for a good while, but usually the Earth changes after a while. It starts building up too much heat. It actually begins to rift apart. And so Pangaea is fairly stable at 237 million years, but later on in the Triassic, it really is going to begin to split apart. So you begin to see it here. And now you can see kind of there's some ocean beginning to rip it apart in here. This is kind of like what's happening in Ethiopia today in that section. And so it's beginning to tear these apart. And by the time we get to the late Jurassic at 152, North America and Africa, along with Gondwana, have split. And now we're starting to make the Atlantic Ocean at this point. It's still growing today, but here's when it started, okay? By the time you get to Cretaceous, in plate tectonics, we call this a passive margin because the ocean crust and the continental crust are moving in the same direction. So sediments can wash down off of the continents, in this case, out of the Appalachians, and deposit in the shallow water in here and not get disturbed. So they just build up one layer after another. This is going to build the whole coastal plain, which you all may know is from about I-95 all the way out to the coast. And all that is just sediments that washed out of the Appalachians, start being deposited in this time period in Cretaceous and keep on going. They're still actually washing out today. We keep going. This map is at the boundary between the Permian and the Triassic. There was you may have known the large meteorite that hit and created global extinctions, including the dinosaurs around this time. You can see where it is here compared to where is the mid-Atlantic up here. Right? That had an effect on here, probably created a big tsunami. But then also, importantly, about 35 million years ago, there was a bolide that came in, another meteorite, and hit in what is going to be now Southeast Virginia at about 35, created a big crater. The crater was later covered over by more sediments of the coastal plain, so we didn't really recognize it, but we have found that it was there. And the point of it is it has an influence on making the Chesapeake Bay. So if we look here, what happened, this is now at the when the glaciers were at their maximum. Glaciers made it down into Pennsylvania, but not into Maryland itself. But whenever the glaciers are covering a lot of land, it pulls a lot of water out of the ocean and lowers the sea level a long way. So the sea level was, for example, probably 60 or 70 miles out from Ocean City and the other similar coastline places here. The rivers could cut much deeper, And then a bunch of rivers were also pulled downhill towards the bolide that happened at 35 million years ago, especially the James, the Rappahannock, some of those rivers in the Potomac. They all drained to one place along with the Susquehanna, and then out to the sea there, but cutting deep channels. So when the water came back, okay, and it flooded those river channels, and this is what really makes the Chesapeake Bay. The main thing to recognize here is we have to kind of help people understand the Chesapeake Bay bolide did not zip down and gouge out the bay itself. Rather, it influenced the course of the rivers that really make the shape of the bay. Okay, so they're related, but it needed the rivers as well. And the other thing to notice is we started this story 1 billion years ago, but the bay kind of is just forming in this last picture. So it's fairly recent. We had to deposit the coastal plain and cut the coastal plain in order to make the bay. So a whole bunch of stuff went on. Okay. So often at this point I stop and ask for questions, but maybe we can take one or two. You want to just do them verbally, or obviously this is kind of the tsunami of information, a quick 1 billion years. Anybody have a question or two?
I haven't seen any questions come in yet about the presentation yet.
Oh, okay, that's good actually. Maybe we'll save it. Maybe we'll save it for later so we can kind of keep going and we see what. So I don't want to take too much of y'all's time. But okay, so that's what's happened to the whole mid-Atlantic, and it's similar everywhere because the collisions affected broad areas and not just one state. Okay, and so what did we get out of this? Well, all right, we want to look at the geology to see what we got. One thing we can do to generalize this, keep it from being too complicated at the beginning, is use the rock classes, which you all know about from school: igneous, sedimentary, and metamorphic rocks. So if you make a map of Maryland which shows those things, this is the kind of map you get. We can kind of come back to this legend, but let me also show you how I'm going to do this. Okay, I'm going to go here. Here, I'm going to go here. So I'm going to show you a website that I put together, and I hope it's going to load okay, and you all will it'll keep up with me in a reasonable way. And I'll give you the URL for this later. It will apply to Maryland if you're in Maryland, but you're close to it as well for other places. It's just called Maryland Geology for Education. This is an ArcGIS Online application. You can actually create your own ArcGIS Online account and play with anything you want, but this one is just freely available, and I'll give you a URL for it at the end. When you open it, it defaults to the legend. GIS, as you may know, consists of a whole bunch of layers, almost like a stack of transparencies. You can turn them on or off as you want them. There's no layers turned on, so it defaults to no legend. So the most important thing to do is go over here. The buttons on the left side are apply to the whole map. There's some white buttons on the right side which apply to individual layers. In this case, the important item to do is click on this button which says layers. Okay, when I do that, I end up getting a list of layers that are applied to this map. Okay, and now we've got something we can play with. There is a get started box at the top. You can use it by clicking on some more help here. I'm going to take it out so you have a little more space. Okay, and then what we have is several different kind of like folders or groups of layers that are here. We have Maryland parks, we have rivers and watersheds, and the way you get to any of these, I tell you what, I'm actually going to go down here to the geology one. We have physiographic provinces, we'll use that, and landforms and geology. But for example, if you see a little arrow on the left side. If I click the little arrow, it opens the folder, and I end up getting a whole bunch of different layers. The one we were just talking about was this one, Maryland rock classes. So I'll turn it on, and it has to think about it for a minute, but eventually draws it. And here's what we got. The same thing that was on the PowerPoint slide, but the point of the ArcGIS Online is now you can zoom to any place you want to go. You can ask questions about individual places and so on. We need to know what these colors mean. So over here in the black buttons on the left, one of them is the legend. And if I click on it, we start seeing the colors that go with each one of these. We'll see I'm not quite sure how long. I hope there's not too much of a delay on these, but probably hope we catch up. The tan is not even sedimentary rocks, it's just sediments. That's what makes up the coastal plain, just sand, gravel, and clay. The green of the Piedmont here, and I tell you what I'm going to do. I'm going to zip over here to the layers again, and I'm going to turn on the physiographic provinces to help with where they are. I can open the folder. I have Maryland physiographic provinces in here. Okay, and I'll turn that on. Makes red lines that you can see eventually. And let me come back to the legend we had. Okay, so this is the coastal plain in here where it's tan. The Piedmont is up in here. Most of it is green, and so is the Blue Ridge. The green you can see over here is metamorphic rocks. And then the yellow out here in Western Maryland and a little bit of the Frederick Valley is sedimentary rocks. So this can help you all if you're looking at the different provinces to see what's in different places. Okay, if I go back to, I'm going to use this slide as a better, easiest way to do this one. Yeah, here. Okay, here's what we saw in the ArcGIS Online project. I can also, I'll point out here that the province boundaries often follow the rock class boundaries. So the red lines enclose one color. The rocks largely determine those landforms, and so the provinces usually have that in common, all within the province. But the next thing to really recognize is once you see those provinces for Maryland, it turns out if you those also apply to the rest of the provinces all up and down the East Coast. The Piedmont is and the Blue Ridge are metamorphic rocks. The Valley and Ridge and the plateaus are sedimentary rocks everywhere. You might notice we don't have very many igneous rocks. We do have them scattered around in small areas, but what's happened is there used to be more of them, but in all those collisions, a lot of the igneous rocks got turned into metamorphic rocks. So now we have a lot more metamorphic and not very much igneous, okay? But the nice part about this is that now you know that if you're collecting fossils or crystals that have formed in the coastal plain sediments, you can know they're going to be all in here and on all the way down to the southern United States. If you're looking for metamorphic minerals, here's where they'll be. Or if you're looking for fossils, for example, in the sedimentary rocks in the plateau and the Valley and Ridge, they'll extend all through here. So it kind of helps you. Where should you look for things? Okay, so the next step on this, that was the general kind of view. The next step would be individual ones. You all probably already know that geologic maps show the rocks of an area. As a general rule, those are called formations. Common format for a formation name is a type locality where it was first studied plus a rock type. So I've already used one example, the Baltimore Gneiss, Catoctin Metabasalt, Antietam Sandstone, Wills Creek Shale. All of those are examples of formation names that we might want to find out, okay, what's the rock in a particular quarry or a particular location? Okay, so now we need to go back to ArcGIS Online. Go back here, okay? Okay, I'm going to go to the layers. We'll see how much zoom skips on this for you all, but hopefully you can kind of see what I'm doing. I'm going to go back to the geology and turn off the rock classes because I don't need them. But what I'm going to do is further down for Maryland geology, there is a fairly a newer one that's only in Western Maryland. But if we want to do the whole state, we have to go back to the 1968 map. And that's not too bad because of course, the rocks haven't changed much. Sometimes the interpretation changes, but otherwise it's okay. And so what you get is now we have a detailed geologic map of the state with all the different formations. It's pretty cool, a pretty map, lots of different colors, but also pretty complex. In order to make some sense of it, what we can do is zoom in anywhere, and I'm going to click on one rock type. And what it's going to do is, first of all, it tells me what province is this. It tells me that's the Valley and Ridge because this pop-up will always tell me about every layer that's turned on. So this is one layer. It says up here in the corner, it says 1 of 2. So I'll go to the other one that's here. And what it gives me is formation information for the rock I clicked on. I'm going to dock this a little bit so it's a little bit bigger. Okay, sorry. Da, da, da. And we'll just go with this. It's okay. And it's probably going to be hard to read on Zoom, but if you look at it in your computer itself, once you have the URL, it'll be easier to see. For each rock, there's a name of it. There's a tells you what kind of rocks are mainly there. In this case, it's mainly limestone, but there's also some some shale and some other things that are in this one. Gives you an age, tells you where it is, gives you a thickness, tells you what kind of fossils might be found in it, that kind of information, what was happening in plate tectonics at the time it formed, things like that. A lot of information that's there for every rock that's on there. So especially if you're in Maryland, you can also, there's a search button, you can type in your address and find out what's under your house. A fair number of states have similar web pages to this, and I'll have some list of them at the end when I put them in the chat. But you all may also be aware of it. But what this does is help you figure out what rocks are where when you start looking at stuff. Okay. Okay. Here. By the way, what happens is the landforms also help us find what rocks are where. And so it's worth talking a little bit about what makes landforms. In general, it's two main factors. I'll put them both up. It's called rock character and weathering. Rock character includes what kind of rock is it and the geologic structure, that is, how do the layers lie? Are they horizontal? Are they tilted? Are they folded? All that kind of stuff helps determine the rock itself. And then it's exposed to weathering, reaction to air, water, and so on, and it wears the rock away. Less resistant rocks tend to wear away faster. They make valleys. More resistant rocks weather slowly, and so they often are the high spots. So this can help you figure out what rock is where. Is it in the valley or not? Interestingly, I always kind of point out this is similar to the two things that control in plants and animals, heredity and environment. It's interesting to see the parallels between the way the physical world evolves and the way life evolves. And it means there's no two living things are identical, no two landforms are identical either. So in this process of what's going on in the past and now changes things, okay? So we can these are the kind of things we look for to help us find the rocks and the landforms, okay? And what do we get, by the way? Of course, the solid rocks are more resistant than the loose sediments of the coastal plain. It's one of the reasons why the coastal plain is flat and there are really no mountains out there. It's also never been uplifted. A lot of the igneous and metamorphic rocks may be more resistant than sedimentary, but not always. There are some that get close to each other. And specifically, if you're looking for rocks, conglomerates, sandstones, and quartzites will be slow to weather and they make the mountains and ridges, whereas in our wet climate, limestones, shales, and marbles weather faster and they usually make the valleys. And so that's where you might find them when you're looking for minerals or specific rock types when you're out there looking. So, okay, how do the rocks and structures make what we find in Maryland and the other provinces? Well, let's work our way through the provinces kind of quickly and we can see what we see. We'll start in the West. We're also going to be using cross sections, which you may be familiar with, where you kind of draw a line across the land and cut it like a cake and look at it from the side. And it'll also help us see how that reflects the history. So if I first of all start out in the West, with the plateau and the valley and ridge. A little diagram up here in green shows some red lines. That's where we're cutting the cake across there. And then it says we're looking to the north from there. What we see is folded rocks. These are all sedimentary rocks, broad folds in the plateau, tighter folds in the ridge and valley. And that's how they're different. Okay? If I kind of zoom in on the plateau, it tends to be some broad folds, and the most interesting one to kind of pay attention to in this case is the gray on this map. It's the Pottsville unit, polycyclic group, which includes a sandstone, which is pretty resistant. You can see it's all been gently folded. The actual mountains are at this spot of these vertical lines. And what you actually see is this is what's called an anticline, a fold that goes up like this. And you'd think, oh, well, that should be the high spot. Well, it actually isn't, because the top of this has gotten eroded away over time. But what happens is, because the sandstone is right on this spot, it makes a mountain, in this case, Winding Ridge. And the sandstone is also right here, two parts of that fold, and that makes Negro Mountain here. Then it swings under here, and now it's at Meadow Mountain, makes it here, happens again over here to make Backbone Big Savage. We're here. So interestingly, what happens is we don't always find the structure, which is the anticline. The upfold is necessarily the topography. They don't always match. Sometimes they're different. This diagram may help some too. Here's an anticline. Once we get it going, there's an anticline, okay? But the high spot isn't in the middle of this fold. It's right here where there's a resistant rock, okay? And we even have another kind of fold, a syncline that goes down like that, okay? It does happen to be a low spot here, but we have mountains along the spot where we have a resistant rock. So the main point is this one, the folding puts the rocks in their locations. Then the rock resistance determines if that becomes a valley or a mountain. So it's not just the folding that makes the mountains, it's also the way they weather. So we always have to look at both to see how it comes out. Okay, moving to the valley and ridge. Sometimes the structure and the topography match. Okay, so over here on this side, we have an anticline, a fold that goes up and back down, and it is also a mountain here because it is a resistant sandstone. But another over here, we have also a spot where it agrees. This is a syncline, and it has a non-resistant rock in the middle, so it also makes a valley. So there's a spot where they match. But here's a couple places where they don't match. You can see the little vertical line for a mountain at the spot where there's a syncline, a fold that goes down. You would think it would be a valley. This is a good example of This is Town Hill and Sidling Hill are good examples of where the topography and the structure don't match. I expect many of you will have driven through the interstate cut in through Sidling Hill. It's one of the nicest road cuts in the eastern U.S., really, because of what it shows so well. You can see overall it is a fold that goes down. It is a syncline and comes back up on the edges. And you think it would be a valley, but no, it's got a resistant sandstone up here at the top, and that keeps it from wearing away. So it's a really good example of how the topography and the structure don't always match, but we can understand how they go together. Okay, that's the valley and ridge, okay? Here's a bigger cross-section across the valley and ridge. The line is down here on the lower right of the sections through Allegheny County and into Washington County. And what they show is the black lines are resistant sandstone that keeps reappearing. And every time it appears again, it makes another mountain in those spot. It then may be buried for a good while before it comes up again. But often the same sandstones, just 2 or 3 of them, make all the ridges as they go up and down. Moving on to the Blue Ridge. Same basic idea happens here, but not quite so complex. It's one big fold. Following this dotted line, this is the Weaverton quartzite that was folded this way and eroded off the top again. Okay? So what it leaves us with is 2 areas that are resistant quartzite at the surface. One over here that makes South Mountain, and one over here that makes Catoctin Mountain, which is a little broader because it's not so steep. And so we have two main ridges in Maryland because of the Weaverton quartzite. It's very resistant, much more resistant than the limestones that are over here in the Hagerstown Valley, as well as the sedimentary stuff, which is in the Frederick Valley. So they really stand up far above those 2 valleys. Interestingly, the other thing that's going on here is the layers you see here in yellow with little dots is the Catoctin metabasalt. I mentioned this is when Rodinia was breaking up, It puts basalt on the land, volcanoes. So here's a layer of lava basically in Maryland, and it does extend into Virginia and other places. It happened when Rodinia was rifting. And then you also see a fault over here that happened when Pangea was rifting and made Frederick into a rift valley as well. So the continents have rifted twice in this area, but 400 million years apart. Kind of makes interesting stuff. If we go to the Piedmont, I'm going to put a whole bunch of these up at once so Zoom can catch up. Okay. These are quadrangles in the Piedmont cross sections that you find, and what you see when you start looking at them is you find these little folds and loops that go down and pieces that go up and back down and other loops. It looks kind of complicated. So my analogy for the Piedmont geology is it's a train wreck. Fortunately, no one was injured in this train wreck, but it kind of shows analogous things happening. Things like we have the locomotive is right next to the caboose, but hey, they're not supposed to be together. Well, in geology, usually the older rocks are on the bottom and younger as you go up. Well, in the Piedmont, we have ones that are switched around. So the oldest is on top. So they've really moved a long way. You'll see in our train wreck, we have cars and freight scattered around. This happens in the Piedmont as well because we have rock units that are scattered around, a piece here, a piece there, so forth, rather than being continuous because they've gotten folded and squeezed so much. And then we might ask, what is a passenger car doing in the middle of this freight car wreck? Okay, well, we have very unusual rocks in different places where ocean crust has gotten pushed up onto continental crust where they don't belong. Even parts of the mantle show up in the Piedmont and make the serpentine barrens. So the different things get mixed together. And then, as if it wasn't hard enough, when you have to try to figure this out, it's a buried train wreck. Okay? You have to try to look through, just get little pieces sticking up here and there, and you have to figure out what's going on. So that just makes it more fun to do geology. Right? And so what do we figure out? What do we find? We find there's a whole lot of folds in this. Here's one cross section from the Union Bridge quadrangle. You can see how many folds there are in it back and forth. There are pieces like this, which where you can imagine taking a piece of paper and folding it in half and then start folding it into like a fan fold sort of thing. You get many folded surfaces. That's what's happened in the Piedmont. Lots and lots of crazy stuff. Okay. And here's an example of a cross section which shows one of the domes where it goes up and comes back down again. This is kind of like throwing a blanket over a bed and it's got lots of wrinkles, but then cut off the tops of all the folds. This is what's happened in the Piedmont. Lots of metamorphic rocks really formed in the roots of the mountains, but now worn down to be exposed at the surface. Here's an interesting example of also what happens regarding the landforms. This is the elevation picture from the LiDAR image showing an area just north of Baltimore City. This is Baltimore City down here at the bottom. You can kind of see the squared off parts. And the green areas on this are valleys. They are things like the Green Spring Valley, Lutherville, Timonium, Cockeysville, so forth. They go all the way up through here. The yellow parts are higher areas of land. And so you can see it's kind of random green and yellow around, but let's see if we can find any pattern to it. First of all, by the way, I noticed you all are going to the Texas Quarry for our trip. This little spot in the middle where it's white is the Texas Quarry. And it's a big hole, and it's gone all the way down to the colors that are there for almost sea level because it's been dug so deep. So you all can see what's at the bottom. But it's part of the Cockeysville Valley through here. If I overlay the geology on this, and I'll also go ahead and put on some names. The blue is the Baltimore gneiss. That's the billion-year-old stuff. The Setter's quartzite is a resistant rock. The Cockeysville marble is the tan that's in through here, and the Lochraven schist is the yellow that's here. And so what I can do is change the color so that's just outlines instead of colors. Okay, and what we can begin to notice is the geology, which is the white lines, ends up outlining the topography because they're so well matched. So, for example, this yellow in here is all Loch Raven schist. I can also put the labels back on, and it's all high. But we go to those green areas that we were looking at earlier. That's the valleys. They're all in the Cockeysville marble, including the Texas Quarry right in here. Because the marble wears away. It's just calcium carbonate. That's the same thing you take when you have a Tums and settle your stomach. They dissolve slowly in rainwater, and so they make the valleys north of Baltimore, whereas the schists and the gneisses and so forth make the hills. So it's another example of how the rock has created the landforms, and they also help us find the rocks. Where are different ones? And like I say, the Texas Quarry is that big hole in the Cockeysville marble, right? Okay. So if we summarize all those 4 provinces, we have the plateau, which is broad folds. We have the valley and ridge, which is tighter folds, and it also has faults. The Blue Ridge is folded and metamorphic rocks, and the Piedmont is complex folds. Everything's squished together. Interesting, what this shows us is which side did the continental collision have to come from? It has to have come from the right because that's the area that's most deformed. And as you go to the left, we get less and less deformation. And so this is what's happened on the whole mid-Atlantic. Okay, more deformation of all to the east and less as you head out all the way to the plateau. Except we still have to talk about the coastal plain. You'll see where the cross section is up here. It's all the way out kind of to the bay. But what happens if we move this out of the way? I'm going to push all of this picture out of the way to the left. I don't know how it'll come out on Zoom, but okay, I'm going to move it out of the way because now I can put on the rest of Maryland and the rest of the coastal plain. Okay, it's a whole bunch of sediments that starts around, Howard County in here, and heads all the way out to Ocean City, depending on where you are on the coastline. There's what the coastal plain looks like. So now we need to talk about this briefly. The coastal plain landforms, as you all are probably aware, low hills on the western shore, flat and level on the eastern shore. If you're driving out to the beach somewhere, it's like that. The rocks are not really rocks. They are sediments, unconsolidated sand, gravel, clay, so forth. There are some iron cemented sandstones and conglomerates. I'll show a picture of those in a minute. Which have formed as the groundwater goes through the sediments, and it may start depositing out iron oxides, hematite and limonite, those sorts of things, and glue everything together. It looks a lot like horizontal layers when you look at the big picture. Here's a picture of the iron cemented sandstone and conglomerate. You all might have collected some of these and look for crystals. Here's a really big iron cemented conglomerate, got much bigger chunks in it. Okay. And here's a kind of picture of the horizontal layers that you get. The white and the browns are arranged that way. And here's one that's a fairly famous area, Rocky Point, near Calvert Cliffs. Again, everything looks horizontal. As it turns out, it's not exactly horizontal. If I go over to here, this is that cross section that I had from Howard County all the way out to Ocean City, cut up into 3 sections. So as you get out to this edge, it connects back to this one, back to the other one, so on. The main thing this one allows us to see is it really is a wedge shape. Okay, it's very thin at the northwest end, okay, but gets thicker as you go to the southeast. And if you can read it, it shows at Ocean City, it's 8,000 feet thick. Okay, that's a lot of sediments that are out there. If you continue this out into the continental shelf, it's 15,000 feet thick. And this is how we get an idea of how big were the Appalachians before. If we take all this sediment and we put it back on the land, you get mountains that are going to be thousands of feet high. So that's the other thing that the coastal plain tells us is how high were those mountains, and here's everything that's left now. Again, this is the place you would go for Calvert Cliff fossils and other fossils in some of these, and minerals that get deposited in the sediments like that. So we have all these structures in the provinces in different places. I kind of put these descriptions up. There we go. And wherever you are, if you're in Pennsylvania or Virginia or West Virginia, some of these same things apply for wherever you are. And I hope that kind of helps you with figuring out what's where in different places. Just real quick, I'll go back over here for 1 second. I'm going to turn off some of these layers. This is just so you get an idea of what's here. One thing besides the actual layers that are added. Oh, and by the way you turn one of these on, any layer on, it's got a little eye with a slash through it. That means it's not visible, but if you click on it, that makes that layer visible. It becomes an eye without a slash, or if you move the cursor away, it doesn't have a icon at all. So that's the place to click when you want to turn something off again. Okay, I'm going to turn off the geology layers, one at a time. Yeah. That's how that works. The other thing that's interesting about this is you have lots of good maps with Google Maps, for example. The GIS will give you more base maps. So if I go down to this item on the left menu, it's just base map. I click this, give it a little time to fill some in and for Zoom to catch up. You can see actually there's a whole lot of different base maps I could use for what's underneath the layers. So that's an item to play with. Truth be told, if I start zooming out, this map, which we've been concentrating on Maryland and the kind of mid-Atlantic, is actually a whole world map. So you can always go out to the whole world map. We could spend another few hours going up here to edit and add layers. You can add layers of any kind that you want. So you can play with this. You can actually create an account and save things. So you can play with ArcGIS Online and click on anything, right click on something, see what you get, keep playing. You can't mess it up. Just go back to it. Just start over if you ever get lost. So lots more layers there to play with on. Here, we'll go back to here briefly. As it says, it's got the provinces, the U.S. provinces, and rivers and watersheds. You want to find out what watershed you live in, things like that. So the ArcGIS Online can do lots of things. Okay, so I'm going to come back over here. Okay, so I said I'd give you some websites at the end. Here we go. I'll show you these first on the PowerPoint slide, and then I'm going to put all of this into the chat. All these. So it's the Earth Viewer one that we started with for Rodinia. We've been watching the 2D view of the Maryland Geology for Education. There's also a 3D one that you can tilt and see from the side. A listing of some of the other states' geologic map websites. You all may have these for your state already, but there's a few more. All right. For you need the whole U.S. Geologic map, there's one at the USGS at the MR data site. There's a second one there, and the newest one is what's called a cooperative geologic map. So I'll put all these URLs in the chat in a second. And perhaps the most important one that you all might use if you're going to go out and collect somewhere is the National Geologic Map Database. I'll give you that URL, but particularly if you'll notice, if it reads it, if you see it says Map View down here at the bottom, that takes you to this view. And what you can do is zoom in on any place you want. You can click on it, and let me try it. Because that'll help if we actually do this. Okay, I'm going to go up here. Sorry. It's going to fill this in for me. We'll see how long it takes and how long it takes for Zoom to catch up. The map view can take you any place you want to look. And once you get there, you can do a search and go to a specific name spot. But once you get there, you can also just click on the map. And then what happens is, again, I'll give it a little time to catch up so you're seeing it. It shows the quadrangle map, which is for that area over here on the upper left. So now you have the quad map. And then if I click on the quad map over here on the upper left, it takes me to a place where I can, you can see it says a map preview. Again, I'll give it a few seconds to catch up. Shows me where it is. Okay, this is as though you downloaded a paper copy of it. So now I can click on it as the map preview, and it shows me the map, and then I can zoom in on the map and find any place I want. And then the other nice thing for this is, like I say, I can scroll around to get any place on the map. I can then read the rock descriptions and see what minerals might be listed in there and things like that. So this is a way to get a detailed, the best geologic map you can find for anywhere in the United States is through the National Geologic Map Database. Okay, so what I want to do is I'm through with what I needed to show you. And now what I'm going to do is pop back over here. Let me go get the list of all this stuff. And I'm going to drop all that in the chat. And we couldn't possibly have any questions. There's only, like I say, only a billion years that we had to talk about here.
So far, we've just got a couple comments saying this is so informative. I could listen to you all night. Great information.
Yeah, sorry, it's just a long time. I'll just throw this stuff in and you all can move on to your meeting.
Oh, all good. Thank you, sir. Thank you, Martin. That was awesome. This is recorded, so those URLs that were on the screen, if you don't grab them from the chat right now, you'll be able to go back and get it on YouTube. You'll have to manually type it out.
Just select them all and save it to a Word document or text, and you got them.
Yeah, definitely.
Thank you for your patience. I hope that covered a few things of interest.
Absolutely, did for me. I'm horrible. I've got a whole bunch of books at home, and I'm horrible with the online stuff at this point. So this is going to be a great resource for me personally. So thank you, Martin. That was amazing. Thank you. Does anyone have any questions for him? A bunch of thank yous. Whole bunch of thank yous. Cool. All right. Yeah, cool. So let's do the giveaway, everybody. We have a bunch of people. Becky Connolly just came.
I was going to say, I've been tracking, getting all the numbers, and yes, thank you also, Martin. And I have to say, I did use the Maine one up in Maine when we were going to build to understand the the ground underneath where we wanted to build, and found out we couldn't build there. But so it comes in handy. Okay, I've been tracking numbers, and right now, Joe and Mike Fowler, you both chose the same number. So those will need to be. Becky, you answered one of my questions because, so Alex and Becky, and then there was George's iPhone. Did you have a number you wanted to choose? And there were several others who hadn't put in.
That's that
are still here.
Yeah,
they're still in the meeting.
All right. Well, here you go. You have got 5 seconds to get your number in, because I'm going to switch over.
I've got to get through this. Alex. Okay, Nicole. Okay.
Cool. All right. Well, I'm going to go over to. All right. Random.org. And we're going to put in 1 through 500. And all right. 5, 4, 3, 2, 1. Here is the winner. 141. Closest without going over. So
okay, hang on. I need to resort and make sure. Let me resort again. Yeah. Okay. All right. What was the number again?
141.
141 without going over. Congratulations, Bill Geary.
he's messaging. Maybe pick me. Yeah. All right,
And-
Bill, you won. You've got all this stuff except for maybe the area
Yeah,
of
really.
crystals.
Yeah.
So it's all good. It's coming at you the next time I see you.
Congratulations, Phil.
All right. So awesome. Congratulations, Bill. Okay, so just last couple things. You can give all but the 52. You're the closest. You're the next closest. All right. All right. So who is the next closest? You can give all but the 52 to the next closest. So Bill's giving it away. Should we go again? Who's closest to 141? Sylvia, you're muted.
Sorry, I clicked the wrong button. Bruce, if he's still on, Bruce chose 128.
All right. Bruce.
Let's
Hey, I'm
see.
here.
All right. What is your
Yay.
last name, Bruce?
This is Bruce Cohen.
Oh, okay. Bruce Cohen. All right. So you won the rest of that. So
Excellent.
I'm writing that down.
I never win anything.
You just
Well,
did.
You did tonight.
I'm just going to start
so-
a streak now.
No worries. Bill, I will throw in a couple extra Area 52s. And Bruce, I will replace a couple, the big one with a smaller from the trip from
Works
my
for me.
personal stash. So congratulations, both of you. That's probably the first time we've had double winner on the night. So thank you, Bill, for passing
Yes.
that on.
Thank you.
So.
Thanks, Bill.
Cool. All right. So, last couple things for the night. Next month is daggone close to the July 4th. So, we're going to make it a 250th anniversary special. We have been discussing in the team chat. We're trying to figure out how to do a special giveaway. We'll be announcing that. Other than that, next meeting is going to be, I'm going to present on how Jack's Mountain basically helped build this country and discover new universes. So Jack's Mountain is right here in Pennsylvania. So that's what I'll be presenting on next month. And then the month after that, we will have Johan Mertens on with doing some calcite stuff. So that'll be the next couple of months. We're going to try to get out another field trip announcement email out this week for the rest of July stuff. That'll be coming. Leadership team, does anyone have anything they'd like to say? Joanna, you're muted somehow. If you were just saying something. Nope.
I'm good.
All right. Tina's good. Joe, you good?
Do you
I'm
want me
good.
to say the number, Andrew?
So everyone, go ahead, Sylvia. I'll let you have the fun.
Well, we hit, as of last night, we hit 500 members officially, paid members.
So
So thank you all. It's huge.
congratulations, everyone. We are getting quite large.
All right, I fixed my mic.
Ah,
So before we wrap up tonight, I'd like to take a quick moment to talk about the Bedrock Bulletin again. Andrew did a great recap of what we're looking for, but I'd like to reiterate that the newsletter belongs to all of our members. We're always looking for field trip photos, trip recaps, collecting stories, mineral and fossil finds, educational articles, club memories, and member spotlights. If you've had a great day in the field, you learned something interesting, or you just have a specimen you're really, really excited about, we want to feature it. You don't need to be a professional writer. Send me your photos, a few sentences, or even just an idea, and I'll help you put it together. The Bedrock Bulletin is at its best when it reflects the experiences and knowledge of our entire Geology Club family, and we are one great family. If you've been thinking about contributing, this is your sign to do it. We want to hear from you.
I'm sorry, Joanna. I should have had you do that during the card. My apologies.
No
That was
worries,
great.
no worries.
A lot better than my version. All right. Did anyone else have anything? If not, well, thank you all for being here. We really are humbled and gracious and grateful for all of you and for being here and making this the family that it is. We are working our tails off to bring you the best that we can. We're all kind of maxed out, so we're bringing in new people. We will. We do have a couple more people that are joining our team, our greater team, to help us fulfill everything that we need to do. But just so you know, we're dedicated to you all. We're members first here. This isn't about growing the club. This is about growing the family and the community. So thank you all. And with that, I'm going to say goodnight to everyone. So thank you all and good night. We'll see you next month.